Good wishes to all of you. Social Science, The Earth Our Habitat, textbook in Geography for Class 6, Chapter 3, Motions of the Earth. Take a look at Figure 3.2, Day and Night on the Earth due to rotation. Take a look at Figure 3.1, Inclination of the Earth's axis and the orbital plane. As you know that the earth has two types of motions, namely rotation and revolution. Rotation is the movement of the earth on its axis. The movement of the earth around the sun in a fixed path or habit is called revolution. The axis of the earth, which is an imaginary line, makes an angle of 66.5 degrees with its orbital plane. The plane formed by the orbit is known as the orbital plane. The earth receives light from the sun due to the spherical shape of the earth. Only half of it gets light from the sun at daytime. Figure 3.2. The portion facing the sun experiences day while the other half away from the sun experiences night. The circle that divides the day from night to the globe is called the circle of illumination. The circle does not coincide with the axis as you see in the figure 3.2. The earth takes about 24 hours to complete one rotation around its axis. The period of rotation is known as the earth day. This is the daily motion of the earth. Let's do. Take a ball to represent the earth and a lighted candle to represent the sun. Mark a point on the ball to present a town X. Place the ball in such a way that the town X is in darkness. Now rotate the ball from left to right. As you move the ball slightly, the town will have its sunrise. As the ball continues to move, the point X gradually gets away from the sun. This is sunset. Do you know the ancient Indian astronomer Aryabhatta had started that the earth is round and rotates on its own axis? Take a look at figure 3.3, revolution of the earth and seasons. What would happen if the earth did not rotate? The portion of the earth facing the sun would always experience day, thus bringing continuous warmth to the region. The other half would remain in darkness and be freezing cold all the time. Life would not have been possible in such extreme conditions. The second motion of the earth around the sun in its orbital is called revolution. It takes 365 and half, 365 fourth days 1 year to revolve around the sun. We consider a year as consisting of 365 days only and ignore 6 hours for the sake of convenience. 6 hours saved every year and are added to make one day 24 hours over a span of 4 years. The surplus day is added to the month of February. Thus, every fourth year, February is of 29 days instead of 28 days. Such a year with 366 days is called a leap year. Find out when will the next leap year be. From the figure 3.3, it is clear that the earth is going around the sun in an elliptical orbit. Notice that throughout its orbit, the earth is inclined in the same direction. A year is usually divided into summer, winter, spring and autumn seasons. Seasons change due to the change in the position of the earth around the sun. Let's do. Do you know how to draw an ellipse? Take a pencil, two pins and a loop of thread. Now fix these pins on a paper as shown in the figure. Put the loop on the paper enclosing these two pins inside the loop. Now hold the pencil and draw the line keeping the thread tight and moving the pencil along it. The figure represents an ellipse. Let's do. To understand the earth's inclination in the same direction, draw a big ellipse on the ground and take a flag with a stick. Stand anywhere on the line of the ellipse. Point your flag to a fixed point far away like on a treetop. Now move along the ellipse keeping your flag always pointing towards that fixed point. In this way, the axis of the earth remains inclined permanently in the same position. The revolution of the earth and the inclination of the earth's axis in a fixed direction cause seasons. Look at the figure 3.3. You will see that on 21st June, the northern hemisphere is tilted towards the sun. The rays of the sun fall directly on the tropical of Cancer. As a result, these areas receive more heat. The areas near the poles receive less heat as the rays of the sun are slanting. The North Pole is inclined towards the sun, and the places beyond the Arctic Circle experience continuous daylight for about 6 months. Since a large portion of the northern hemisphere is getting light from the sun, it is summer in the regions north of the equator. The longest day and the shortest night at these places occur on 21st June. At this time in the southern hemisphere, all these conditions are reversed. It is winter season there. The nights are longer than the days. This position of the earth is called the summer solstice. On 22nd December, the Tropic of Capricorn receives direct rays of the sun as the south pole tilts towards it. As the sun's rays fall vertically at the Tropic of Capricorn, 23.5 degrees south. A large portion of the southern hemisphere gets light, therefore, it is summer in the southern hemisphere with longer days and shorter nights. The reverse happens in the northern hemisphere. This position of the earth is called the winter solstice. Do you know that Christmas is celebrated in Australia in the summer season? On 21st March and September 23rd, direct rays of the sun fall on the equator. At this position, neither of the poles is tilted towards the sun, so the whole earth experiences equal days and equal nights. This is called an equinox. On 23rd September, it is autumn season in the northern hemisphere and spring season in the southern hemisphere. The opposite is the case on 21st March, when it is spring in the northern hemisphere and autumn in the southern hemisphere. Thus you find that there are days and nights and changes in the seasons because of the rotation and revolution of the earth respectively. Exercises. Question number 1. Answer the following questions briefly. A. What is the angle of inclination of the earth axis with its orbital plane? B. Define rotation and revolution. C. What is a leap year? D. Differentiate between the summer and winter solstice. E. What is an equinox? F. Why does the southern hemisphere experience winter and summer solstice in different times than that of the northern hemisphere? G. Why do the poles experience about 6 months day and 6 months night? 2. Take the correct answers. A. The movement of the earth around the sun is known as. B. Direct rays of the sun fall on the equator on. C. Christmas is celebrated in summer in. D. Cycle of the season is caused due to. 3. Fill in the blanks. A. A leap year has dash numbers of days. B. The daily motion of the earth is dash. C. The earth travels around the sun in or dash orbit. D. The sun's rays fall vertically on the tropic of dash on 21st June. E. Days are shorter during dash season. Things to do. 1. Make a drawing to show the inclination of the earth. 2. Record the timings of sunrise and sunset at your place, taking help from your local newspaper on the 21st of each month, and answer the following. A. In which month are the days the shortest? B. In which months are the days and nights nearly equal? For fun. 1. Draw different shapes of ellipses by placing 2 pins nearer and farther using the same loop of thread. Notice when the ellipse becomes circular. 2. On any sunny day, take a straight stick that is 1 meter long. Find out a clean and level place on the ground. Place the stick in the ground where it casts a distinctive sharp shadow. Step 1. Mark the tip of the shadow with a stone or a twig or by any other means. The first shadow marks is always towards the west. See after 15 minutes and mark the tip of the shadow again. By then it would have moved a few centimeters away. Now join the 2 points and you have an approximate east-west line. Step 2. Stand with the first mark to your left and the second mark to your right. You are now facing north. This fact is true everywhere on the earth because the earth rotates in west to east direction. An alternative method is more accurate but requires more time. Set up your shadow stick and mark the first shadow in the morning. Use a piece of string to draw a clean arc through this mark around the stick. At midday, the shadow will shrink or disappear. In the afternoon, it will lengthen again and at the point where it touches the arc. Make a second mark. Draw a line through the two marks to get an accurate east-west line. Thank you.